Okay, so we are assigned an induction proof here. We're going to start off with our base case because 1 is the lowest term in the summation here. We're going to do n equals 1. Then we have 1 squared equals 1. We want to show that is equal to this. So we'll just plug in 1 in place of n. So we have 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6, which equals 2 times 3 divided by 6, which equals 6 divided by 6, which equals 1. Therefore, we have proven the base case. Now, for our inductive hypothesis, we assume that for up to n, including n itself, the property that from I equals 1 to n, the sum of all the squares is equal to n times n plus 1 times 2n plus 1 over 6. And we want to show that from I equals 1 to n plus 1, the sum of all the squares is equal to n plus 1, n plus 1 plus 1, so n plus 2, and 2 times n plus 1, so 2n plus 2 plus 1, which is equal to 2n plus 3 divided by 6. We want to show that this equality holds. To show this equality here, we are going to note that n plus 1 squared is equal to this. The sum of all squares up to n plus 1 minus the sum of all squares up to n. So we are going to write out these two sums as n plus 1 times n plus 2 times 2n plus 3 divided by 6 minus n times n plus 1 times 2n plus 1 divided by 6. We will take this 6 out, and we will have 1 over 6 times n plus 1 times n plus 2, all the terms in our minus n times n plus 1 times 2n plus 1, like this. And n plus 1 is a mutual term here, so we can also pull that out. So we'll have n plus 1 times this. And then we may expand these terms. So we have 1 over 6 times n plus 1 times, here we have 2n squared plus, that would be plus 3n plus 4n plus 6, I'll put brackets here, minus, then we have 2n squared plus n. We will continue simplifying our terms here. So we will have 1 over 6 times n plus 1, and then we'll have in here these will cancel out, and then we'll have just 3n plus 4n minus n. So we'll just have 6n plus 6, which equals 1 over 6 times 6n squared plus 6n, and then we'll use this term here, plus 6n plus 6. Now all of these 6's cancel out, so we'll have n squared plus n plus n plus 1 equals n squared plus 2n plus 1, which equals n plus 1 squared. So we have proven what we have wanted using induction. Therefore, we are done.